All right, there it is. Section 6.2, complex fractions. These are a lot like your solving questions from section 6.1. So we're looking at trying to do something kind of similar to what we just did in section 6.1. The difference is these are not solving, these are simplifying. So that does kind of put a whole different spin on where we're at and where we're going. So this is example number 1. Let me show you what the front of the note packet looks like. Maybe. Here it is. All right, so complex fractions and rationalizing, and this is what the actual notes look like. But you can see that if you look down the whole thing, they don't really give you a whole lot of room to be able to do the problems. So that's why I wrote them all on a separate piece of paper. They're the exact same questions. They're just written so I can write a little bit larger so you can see better and so forth. All right, here goes. I have it's called a complex fraction because I have fractions within fractions, right? So if I'm looking at this, I've got this whole numerator and this whole denominator, and both are filled with fractions. I do not like complex fractions. So what you do to get rid of them is you turn them horizontal. Go horizontal with it. So right now I'm not going to do any math. All I'm going to do is rewrite this horizontally. So I'm going to take the numerator, u squared over 4 plus u over 4 divided by, and I'm using parentheses to separate my numerator and denominator, divided by 4 over 3 plus 8 over u. And so what I've done is just separated it so I no longer have a complex fraction. So it's still a division problem, just like fractions would be, but it's now horizontal. And what I'm going to do is get common denominators. In order to add or subtract fractions, I have to have a common denominator. So within this grouping, I'm going to get a common denominator. Lucky for us, it already has one. And within this grouping, I'm going to get a common denominator. So that's where it's kind of like that last section was. So we did the similar type stuff with that. So my first group has a common denominator. The denominator is 4, so I can rewrite this, combine them together as u squared plus u all over 4. Common denominator. But the second grouping doesn't have that luxury, right? The second grouping I actually have to get common denominators. So I have a 3 and I have a u. And so when I put them together for my common denominator, it's a 3u. Now you're going to do the matching thing. Remember we did this back when we were doing rational functions. If this has a 3 and it needs a u, I'm going to have to multiply this guy by u. This guy has the u, he needs the 3. I'm going to multiply him by 3. And so my new numerators are going to be 4u plus 24, 8 times 3. You're going to have to throw me in the chat if you get lost on what I'm talking about, because there's a lot to these. All right, so far all I did was got common denominators within the two sets of fractions. And then the next thing I do once I have that is I keep change flip, right? I have a division problem with fractions. So you keep the first fraction the way it is, you change this to multiplication, and then you flip the guy after the division sign. So here's your new setup. Your new setup's going to be u squared plus u over 4 times 3u, remember you're flipping, over 4u plus 24. And you notice at this point I've removed the parentheses. You can keep them if you want to, but at this place you want to see if anything's going to cancel out. So I'm looking, and I can factor a u out of this, but it's not going to cancel with anything down here. So you can leave that as the u squared plus u. 3 won't cancel with any of the bottom. So that's not going to cancel. And I think we're done. I think that's the best you got. So now it's just a matter of putting them together. And there's a lot of different equivalent forms that would be correct. It's your choosing as to how you want this to go. So I could say it's 3u parentheses u squared plus u. That's my top. My bottom would be 4 times parentheses 4u plus 24. That would be one equivalent valid answer. Or I could distribute it through. Take the 3u and multiply it through. Take the 4 and multiply it through and see what that comes out to be. Let's see. We've got 3u cubed. Here's another valid form. Plus 3u squared all over 16u plus 4 times 24, is that 96? There's another equivalent form. So there's several different ways that you could answer this question. If it were a test question, either answer is fine. You can stop right there. That's the same thing. Nothing canceled. So the whole deal is you want to cancel things out if they cancel, but if they don't, oh well. And this is one of those oh wells because nothing canceled out. All right. Thumbs up. Good so far? Sweet. Okay, so example 2. All of these we're going to follow the same thing, the same style, right? We're going to take the complex fraction and we're going to turn it horizontal. Oh, by the way, if you watched the video, he has a whole different way of coming up with common denominators, which is also perfectly fine. It works. It just isn't the way my brain thinks. So I tend to like to teach you the way my brain thinks. So if you do watch the video, realize that he's got a different approach to doing these, to getting those common denominators, which is perfectly fine. It might make sense to some of you. Just it's an alternate way to do it. So I'm well aware that his video approach is different than mine. So I'm all about this horizontal stuff. So I have 1/5. First move is just rewrite it horizontally. Don't do any math. All right, there it is. So no math involved, just rewrite. Then you want common denominators within each set of fractions. All right, I've got 2 fractions. I have a 5 and a 4. So think of the 5 times tables, the 4 times tables. The smallest thing they have in common is a 20. There's your common denominator. But if I want to turn a 5 into a 20, I need to multiply by 4. If I want to change a 4 into 20, I will need to multiply by 5. So 1 times 4 is 4. 3 times 5 is 15. All right, second fraction set, this second set of parentheses. You have an x squared and an x. So you've got to take the higher power. So x squared is your common denominator. The first guy already has it. You don't need to do anything with him. Then you have a plus sign. But the second guy, x, to turn it into an x squared, you need to multiply by x. All right, so I've got a 5 times x is a 5x. So if I do 4 minus 15, this is like a negative 11. I can rewrite this whole thing with combining that to be a negative 11. I'm just going to put it up above. And then I'm going to keep, change, flip. All right, so keeping negative 11 over 20, divided by becomes times, change, and flip. Flip becomes an x squared on top and a 16 plus 5x on the bottom. And again, you're looking to see, does anything cancel? I've got an 11 on the top. That doesn't cancel with anybody on the bottom. Not everybody's got an x, so I can't take an x out. So this is the best I got. Let me put it together. Negative 11x squared over, you can distribute the 20 if you'd like. I'm going to keep it outside. just because I don't feel like multiplying 16 times 20. The truth be known. And there it is. There's an equivalent form. Again, there's different ways you could write it. If you wanted to distribute the 20, you could. That would not be wrong. But nothing cancels, so that's really a very good answer right there. All right, what happens when you've got more complicated denominators? That's your example 3. And again, shoot me in the chat if you want me to slow down or if you need clarification on any of this. So job number 1 is just write it horizontal. 2 over m plus 4 minus 2m over 9 divided by m over 9 minus 4 over m plus 4. Okay. So take one set of parentheses at a time and you're working on coming up with what the common denominator would be. So I'm going to write it down below it. Common denominator. And on the right hand side, this second set of parentheses, I need a common denominator. Well, denominators, just like back in section 6.1, you have to have one of each thing represented. So I need an m plus 4, and I also need a 9. I need one of each of them. Then it's that whole matching thing like we did back in section 6.1. So if this has m plus 4 and it needs to be a 9m plus 4, then I need to multiply this guy by 9. This guy has the 9, but he needs the m plus 4. All right, so here it goes. 9 times 2 is 18. And then it's minus 2m times m plus 4. So if you multiply that out, negative 2m times m is negative 2m squared. And negative 2m times 4 is a negative 8m. I'll give you a second to think about that. Negative 2m times m, negative 2m squared. Negative 2m times 4 is a negative 8m. All right, now I'm going to the second set of parentheses. Guess what? They've got the same denominator. I have a 9. I have an m plus 4. I need one of each of them. Then let's play the matching game. This guy has the 9. He needs an m plus 4. This guy has the m plus 4. He needs the 9. So you take what's already there and you multiply it by the piece. So m times m is m squared. M times positive 4 is plus 4m. And it's a subtraction next, and 4 times 9 is 36. All right, we've got the common denominators. Now I'm ready to keep, change, flip. By the way, nothing combined up here, right? You had a square, an m, and a number, square, an m, and a number. So that didn't, you can't combine any like terms. But watch what happens when I keep, change, flip. It's kind of cool. I will have, keep the whole thing, keep this first guy the way he is. Times, change the division to times, flip. Take a second and check that out. That's kind of fun, because what are you noticing? You've got some canceling going on. We haven't had canceling happening yet. So I have a 9 on the top that cancels with the 9 on the bottom. I have an m plus 4 grouping that cancels with an m plus 4 grouping. And so what that leaves me with are these guys. I have, you can put Do you want to put it in descending order just because we are those people that need to do that? Negative 2m squared minus 8m plus 18 would be my top, and my bottom would be m squared plus 4m minus 36. Now, if they could be factored, you might be able to reduce it even more. The easier one to factor, to think about factoring, is the bottom, right? Because you don't have the negative and all that stuff going on. So let's just think about it for a minute. Do you have factors that multiply to 36 and add to positive 4? So I'm thinking 36. I have 2 times 18, that's not going to work. 3 times 12, that's not going to give me a 4. I have 4 times 9, that's not going to give me a 4 in the middle. I have 6 times 6. I'm just thinking of factors of 36. None of these are going to give me a 4, so this is not a factorable denominator here. So if this doesn't factor, then nothing is going to cancel. So you are done. There's nowhere further to go. This is your final answer right here. Sometimes you'll be able to factor it down more where you'll have more things cancel. In this case, it does not. All right, I'm going to start you on example 4 and have you finish it. So here comes example 4. And you see this one's just a little bit different. Every time he's kind of changing it up just a little bit. First job is no math, just write it horizontal. So here we go. We have x over x plus 1 divided by x over x plus 1 minus 1. Doesn't make you feel like you should just cancel it and the answer is negative 1? And that would not be true. The math police would come and get you. Now remember, these whole number 1s are over 1. So my job number 2 is coming up with what the common denominator is. So I have 2 sets of parentheses. Each one needs its own common denominator. Getting common denominators, you have to have one of each thing represented, right? So you need an x plus 1, and you need a times 1. Well, times 1 is not going to affect it at all. So x plus 1 is your common denominator. Now, granted, it's going to be the same common denominator in the second set for the same exact reason. So let's check it out. I'm matching x over x plus 1. It already has the x plus 1. I don't need to multiply it by anything, so the x stays in x. That's this guy here. But this second guy, he has a 1. He needs to become an x plus 1. He needs to be multiplied by x plus 1. Well, 1 times x plus 1 is x plus 1 with a positive in front. Positive x, positive 1. We'll combine like terms in a second. Let's go to the second guy. He has the x plus 1, so he just keeps the x. Then it's a minus. This one has a denominator of 1. He needs to be multiplied by the x plus 1. But be careful on this one because this is a negative. So negative 1 times x is a negative x, and negative 1 times 1 is a negative 1. So what I really have is, I'm not keep changing and flipping yet, what I really have is 2x plus 1 up top over x plus 1 divided by x's cancel, x minus x, so they cancel each other out. So this guy's a negative 1 over x plus 1. All right, you take it from there, I'll take it from there, we'll see if we match. This one came out a lot shorter an answer than a lot of the other ones we've seen so far. So you keep change flip, you end up with your x plus 1's canceling out. So 2x plus 1 over negative 1, that's a valid form. Or divide that negative 1 through and you get negative 2x minus 1. That's probably the more popular answer to that question. All right, complex fractions. They're not too crazy. They're just, there's a lot of places for small mistakes, so you just got to really be careful as you're going through. All right, ready for example 5? A couple more and then we're going to change up the topic just a little bit. So a couple more like this and then we're going to talk about rationalizing. All right, so here's my next one, example 5. Again, I'm going to rewrite it, so no math. 2 over x minus 5 plus 3 divided by x over 4 minus 3 over x. Now remember, whole numbers have a denominator of 1. And so I need a common denominator for the front set and a common denominator for the back set. Just looking at the denominator. So I have an x minus 5 and I have a 1. So I need the x minus 5. And then I'm comparing. The 2 has the x minus 5, so the 2 doesn't need anything, he just stays a 2. Then I have a plus sign. Well, he's a 1. I have to turn him into an x minus 5, so I'm going to multiply him by x minus 5. So my new numerator is 3x minus 15. Multiplied out, 3 times x, 3 times negative 5. And so there's my numerator. We'll combine like terms in a second. Second set, my denominator, I have a 4 and I have an x. I need one of each thing, so 4x is my common denominator. If I do my comparison, this guy has the 4, he needs the x. This guy has the x, he needs the 4. And so I'm going to create my new numerator. X times x is x squared minus 3 times 4 is 12. So I'm going to combine like terms before I keep change flip. It looks like the only terms I can combine are up here. So instead of rewriting the whole thing, I'm just going to put it right up above. I'll have a 3x. I'll have 2 minus 15 minus 13. Okay, so here's my new numerator. Now let me put it into the keep change flip mode. So I have 3x minus 13 over x minus 5 times 4x over x squared minus 12. Anything cancel? I'm not seeing anything, right? This x, like I can see that there's x's around, but if it's in a grouping with a plus or minus sign, you can only cancel that if you have the like grouping. So in other words, if I had an x minus 5 up top and an x minus 5 on the bottom, then I can cancel. I can't just cancel 1 for 1 because this guy's attached with a negative 5. Same thing goes here. He's attached with a minus 12. So the only way to cancel this group is to have a group up top that's x squared minus 12. So the x's, although they've all got an x, you can't cancel that out because some of them are part of a group that can't get knocked out of there. So really this is all I got. I can't see anything canceling. So I would have 4x times 3x minus 13. That's my top. And my bottom would be an x minus 5 times an x squared minus 12. Now, could I FOIL that all out and give you an equivalent form beyond that? Absolutely. But this is a perfectly valid answer. Again, there's a lot of different places that you can take this. A lot of times, especially for my kiddies here that are going to go into AP, they say leave it in your unsimplified kind of form here, don't take it the extra step. And the reason why they say that is because taking it to the next step could lead to a mistake. What if you FOIL this wrong, right? But you got it right here, this is correct, but you take it the next step to simplify it and you get that wrong, then they take points off. So they say that it's sometimes best to leave it in its unsimplified form, just like this is. Okay, so we're, whatever you're happy with, I'm happy with, but really I would be looking for something like this on a test. If you take it beyond it, that's fine, but this is perfectly good place to stop. All right, last one is a U try. This was on the very back part of the notes. Looks like this. U plus 1 over 2u plus 5 plus 25 over 2u plus 5 over u plus 1 over 2u plus 5, lots of 2u plus 5s in this guy, and minus 2u plus 5 over u minus 2. So here's what I want you to do. I want you to see if you can simplify this guy. Okay, I'm going to give you a head start, and then I'm going to try it too. We'll see if we match in the end. This is the last one before we change up the topic. So see if you got it. That second set of parentheses got kind of messy. All right, is anybody with me so far? We're close to the end. I'm going to go left to put my answer here. All right, here's your goal. Hopefully you got there. U plus 26 over times u minus 2 over 3u squared minus 21u minus 27. Any yeses or no in the hood? That was a fiery fist of pain. Now, don't you, though, when you get done a problem like that, don't you look back and say, oh, jeez, look at me, I'm so smart. Look at what I just did. That's kind of my thought. There's sometimes, like, especially like in calculus, you'll be doing a problem on the board, and it takes up 3 or 4 boards to do the one problem, and you step back and you look like, darn, I'm smart. Darn, I got this. Ain't nobody going to mess with me. Yeah, these are big beastie problems. I don't think they're crazy hard. I just think there's a lot to them. A lot of pieces to this whole puzzle. Did anybody think about taking a -3 out of this thing? Because I kind of did, but let me think about it if I did. -3 would be u squared plus 7u plus 9. Right, if I took that -3 out of there. And that's not going to factor. Factors a 9. You've only got a couple choices. It's 1 and 9. Or 3 and 3, ain't going to give you a 7. So if you did think about trying to take that -3 out, that was good thinking, but it just didn't take you anywhere. So that's why I left it in this form. So you do want to kind of think about, does this factor or doesn't it factor? Because maybe you might have had a u minus 2 in the grouping that you could have made it even a better answer. But this one it didn't, so that's where you got. All right. So let me show you the next thing. It's kind of similar. This is remember the name of the section, or the name of the unit was complex fractions. Let me show you. Complex fractions and rationalizing. Well, we just did all the complex fraction stuff. Now we're going to look at the rationalizing stuff. And if you remember rationalizing, that was back with when you have roots in the denominator, right? You can't leave a square, somebody in math said you can't leave a square root in the denominator. So it requires a rationalizing skill. But what happens when you've got ugly rationalizing situations like example 6? Let me show you this guy. See him? He's got a square root in the denominator. And math folks say that's not allowed. Can't have that. Not allowed to have a square root in the denominator. And so here's what you do. Is you multiply by what's called the complex conjugate. So what you have is, and it's all about the denominator. You don't really care about what the numerator is. It's all about the denominator. So if you look at the denominator, or the denominator of this guy, it's 4 plus the square root of x. The only way to get rid of that square root of x is to multiply what's called its conjugate, which means you keep the same pieces. You keep a 4 and you keep a square root of x, but you change the middle sign. I feel like we've talked about this before. If we change the sign in the middle to a negative, believe it or not, that's going to end up getting rid of this square root that's down here, and I'll show you why in just a second. But remember, I can't just arbitrarily pick to choose to multiply this thing by 4 minus the square root of x, because that would change the value of this fraction, and that's not valid. I can't do that. So what I have to do is multiply at the top by the exact same thing. Now let me ask you a question. What's the value of this? What is that equivalent to? Oh, close. Good thinking. Yes, 1. Right, exactly. This is a funny looking 1. All I did was took this fraction and I multiplied it by 1, which is a valid math move. I haven't changed the value of this fraction. I'm multiplying it by 1. And that's craziness, right? So it's just a funny looking 1 that I end up multiplying this thing by. Now, with the top, I'm going to leave it. I'm going to keep us as easy as we can be. So we're going to keep the top as x plus 3 times 4 minus the square root of x. I am not foiling that. Not the top. But the bottom I want to foil because I want to show you what happens. First outers, inners last, right? So first give me 16. Outers give me a negative 4 square root of x. Inners give me the square root of x times 4 positive plus 4 square roots of x. And the last give me the square root of x times another square root of x. That's the square root of x squared. Square root of x squared, they undo each other. So it's going to be minus just an x. And so what happened to this whole thing, right? My top stays x plus 3, 4 minus the square root of x, and the bottom becomes 16, a negative 4 square root of x and a positive 4 square root of x. They cancel each other out. And so I have 16 minus x, and I no longer have a square root in the denominator. So I've gotten rid of it. I rationalized it. Now, if you wanted to, you could FOIL out that numerator. Let me show you what it looks like if you did. It's down here. So if I were to take that, you see I've got x plus 3 over 4 plus the square root of x. I multiplied it by 4 minus the square root of x. If I FOIL it all out, I end up with 4x minus x square root of x plus 12 minus 3 square roots of x. It's a hot mess, right? Nothing combines. And so therefore, for our purposes, to keep things as simple as we can keep it, we're going to not FOIL the numerator. We're just going to FOIL the denominators. Okay? Not that it's wrong to do it. You can if you want to. But again, that can lead to more mistakes than what you really want to have. And what does it matter if it looks like this or it looks like what I just showed you? It really doesn't make a difference. Nothing combined, nothing simplified. It just is big and ugly. So I kind of like it in this format better. Okay, so we'll leave it not to multiply out the numerators, just the denominators. Here comes example 7. This one is similar to what we just did, except the denominator's a little beefier, and we say, so what? We can do this. So all about the denominator to rationalize. Keep the pieces you've got in there, square root of x plus 2 and a 1. But you want the opposite sign in the middle. If this is a negative, you want this to be a plus. The only way you're going to get things to cancel out is if they're opposite signs. And so the numerator has to be the same as the denominator because it's just a value of 1 that I'm multiplying by. And then here I go. I'm just going to put this, my numerator is the sweetest part, 5 minus x, square root of x plus 2 plus 1 outside. There it is, numerator done. Now, let me go back up to example 6 just for a second before I start FOILing this denominator, because really, do I need an FOIL? Hold on to that no for just a second. Do I need the whole FOIL deal? Because what happened with my outers and my inners? They're going to cancel out. And the reason they're going to cancel out is because one grouping's a plus and one grouping's a minus. So my outers and my inners are always going to cancel out. Same thing goes for this. My outers, I get a positive square root of x plus 2. My inners, I get a negative square root of x plus 2. So my O's and my I's, I really don't need to do. But I do need to do my firsts and my lasts. The square root of x plus 2 times another square root of x plus 2 looks like this. Square root of x plus 2 squared. What happens when you square a square root? They undo each other, right? So I actually just have an x plus 2. My firsts. The square root of x plus 2 times the square root of x plus 2 is x plus 2. My lasts, negative 1 times positive 1 is negative 1. Can I make that look any better? And yes, my denominator has a little bit of stuff that I can combine together. Numerator stays 5 minus x, square root of x plus 2 with a plus 1 outside, and x plus 1 on the bottom, and I'm done. I have rationalized that. There is no longer a square root in the denominator. Noah's asking, what if it's like 4 square roots of x instead of 4 plus the square root of x? Okay, so he's saying, let me change my color here just for a second so I can answer his question. 4x plus 3 over 4 square roots of x. That would be back to a question like with basic rationalizing, because it doesn't have an operation in the middle. The difference with these guys in this section is they all have an addition or a subtraction or something like that that's in the middle. So you're always going to see some type of operation in the middle. You're not going to see just a 4 square root of x. If this were your problem and you had to rationalize it, you would multiply the top and the bottom by the square root of x. Because if you did that, that would give you a 4x in the denominator, and you got rid of that square root of x. So the same idea, you're going to multiply by 1, an equivalent of 1, but in this case it would just be you'd only have to multiply by the square root of x. All the ones you're going to see in this section are going to have some type of operation between those things. So that's the difference. That's a good question, Noah. All right, we got 2 to go. So look at this guy, right? This one's not so pretty. Again, you're trying to get rid of square roots in the denominator. So you've got 2 pieces. You have a square root of x, and you have a square root of x plus 1. Well, if the original has a subtraction sign between them, then in order for your outers and inners to cancel, you need a plus. You need the opposite operation in the middle. All right, so, and again, this is an equivalent form of 1. So whatever you have in the denominator is exactly what you have in the numerator. So put your numerator together. Remember, we're not multiplying them, we're just keeping them. 2x plus 1, square root of x plus square root of x plus 1. That is ugly, but that's how it is. Now I don't need outers and inners because I've set it up that they're going to cancel, and I can kind of check that out. Square root of x, positive square root of x plus 1, negative square root of x plus 1 and x. So one's positive, one's negative, outers and inners are canceled. So let's do firsts and lasts. The square root of x times the square root of x is the same thing as the square root of x squared. They undo each other, so you just have an x. Positive times negative is negative. Square root of x plus 1 times the square root of x plus 1 squares that, so I get x plus 1. But be careful, there's a negative sign in front. So how's that going to affect this x plus 1 that I'm writing down? So I really have x minus 1. Ooh, my x's are gone. X minus x, no more x. And so what I'm left with is, you can put it over -1, you can put a -1 out in front, whatever makes you happiest. I'm going to put just a -1 in front. I have a 2x plus 1, my numerator, square root of x plus square root of x plus 1. Technically, that's all over a -1, or just multiply by. I didn't want the fraction. Ain't nobody like fraction. So I just put it as a times -1. If you're dividing by -1, it's the same thing as multiplying by a -1. That's kind of where I'm at with it. All right, ready for the last one? This one is a you try. So you're going to try it. I'm going to try it. We'll see if we match answers in the end. All right, see if you can rationalize that. Get rid of the square roots in the denominator. Watch your signs in that denominator because of that subtraction, okay? So you end up with a denominator that's x plus 3 minus x minus 2. X's cancel. And 3 minus 2 gives you 1. This part is harder than the other. God forbid I was making you multiply out the numerators, huh? That would be really ugly. I'm looking to see on my answer key if I did it on the answer key. And I don't think I did. I kept the numerators just as not FOILed out or not multiplied out. Bella, is there anything I can do to make it better? Do you want to try another one? Yeah, the practice. Yeah, I agree with you. The practice makes these so much better. Okay, anybody else have a comment or thought before we try something else? Okay. All right, so here's where I want you to go next. I want you to go to the practice problems. Let me see if I find mine. I have my filled in version. Hold on. Okay. So here's what the notes look like again. This is your complex fractions and rationalizing. We did all the examples, and we are looking at the practice problems. So checking out numbers 1 through 7. If you look at numbers 1 through 7, pick me one that looks particularly ugly. This one, Jill, is already recorded. Like I'm recording as we go, so I don't have to redo this one. I'll redo the 6-1 though that did not get recorded. But this one's good to go, and I'll upload it onto our page. Number 5. I'm going for number 5. Oh, good call there, Miss Girlfriend. All right, number 5. Now, again, I don't have enough space to do this, so I'm gonna rewrite number 5, but I'm gonna rewrite it into our horizontal mode and take it from there. So this is number 5. Give me 1 second here. You have 2 over x plus 5 minus x squared over x plus 5 divided by x plus 5 over x plus x plus 5 over x squared. Okay. So here is number 5, looking at it in the horizontal mode. Are the practice problems due today? I don't think so, Avery. Let me look. We ended up getting done more today than I thought we would, so deadlines are going to be a little different than what I assumed from the beginning of the period, but let me come back and revisit that. So no, they're not due today. These are going to take some time to do. I would not expect you to get them done today. So the answer is they're definitely not due today, but I don't know when they're due, but we'll talk about that in a minute. Okay, 2 things that I'm trying to divide. I need common denominators in both sets. First one, I do a happy dance because they both have x plus 5s and I'm easy peasy lemon squeezy. Take the numerators, 2 minus x squared. But the second set's not quite so easy. I have an x and I have an x squared. That means my common denominator is the larger, the x squared. And when I do my comparisons, I'm trying to take an x and turn him into an x squared. So this guy needs to be multiplied by x. This guy's an x squared already. He doesn't need to be multiplied by anything. So my new top is going to be x times x is x squared. X times positive 5 is positive 5x. This guy's a plus, so I can just keep it plus x plus 5. Then I can keep change flip, right? So if I keep change flip, I've got 2 minus x squared over x plus 5 times flip x squared over, I can combine like terms at this place, so x squared, 5 and 1 more is 6 x's plus 5. Canceling anything? I'm not seeing anything. All right, x squared, 2 minus x squared up top. Down the bottom, x plus 5, x squared plus 6x plus 5. For some of my more savvy kids, does this factor into x plus 5 and x plus 1? I think it does. This is a perfectly valid answer. You're going to see different equivalent forms, right? So this one here factors into x plus 5 and x plus 1. And the only thing that that's going to do to you is you could also call your denominator x plus 5 quantity squared times x plus 1. Numerator doesn't change. Did I have to do that? No. Nope, I didn't. I could have left it just the way it was. 11 I can do. And then we're going to take a look at our deadlines and due dates and things, okay? So we'll look at number 11 because I think number 11 is one of the rationalizing guys. Cool. All right, so 11 is the second request. I'm going to set it up. I've got m minus 5. I have a square root of m plus 4 minus a square root of 2m. It's all about the denominators for these. Hang on a second, let me fix my shade. There you go. Okay, so you can see it better. I'm multiplying by the bottom. I have an m plus 4. I have a square root of 2m. Top has to be the same. It has to be an equivalent of 1. If this one's a subtraction sign in the middle, then I'm using a plus sign, the opposite. My numerator is m minus 5, square root of m plus 4 plus square root of 2m. on the bottom. Square root of n plus 4, square root of n plus 4 is n plus 4. Positive, negative is negative. Square root of 2m, square root of 2m is 2m. And so then I just combine like terms. Negative 2m plus another m is a negative m plus 4. So my new denominator is negative m plus 4. And you've got the numerator there. M minus 5 square root m plus 4 plus square root of 2m. Cool? So there's one of each to help you along. All right, so let's go back and look at our schedule. Today is Friday. You don't have school on Monday. We don't need to finish the notes, so what we're going to do is do the review sheet. We'll start the review sheet on 6-1 and 6-2 on Tuesday when I see you again. What I'd like to do is go over this assignment on Tuesday. So I'm going to say it's due by the end of the day Monday. So that gives you the weekend to be able to do it. So 6-2 numbers 1 to 12 are due by Monday so that we can go over them Tuesday. That should give you plenty of time between now and then to get that done. And then we'll do the review, work on the review on Tuesday, questions from the review on Wednesday. Thursday's a study day, get done the mastery check maybe. And remember, you're only doing the mastery check for section 6-1 and 6-2 because that's what the test is on Friday. So Friday test, 6-1 and 6-2. We just covered everything. So again, we'll go over. So the due date for 6-2 is by Monday, 1 to 12. And then we'll work on the review sheet, which I think I already posted that. The review sheet, I'll double check, make sure that I did. And I'll also do the video for 6-1 so I can post that as well for you. All right, so your next due date is 6-2, 1 to 12 by Monday, leading towards a test on Friday, 6-1 and 6-2. Good? Does that give you enough time? You feel good with that? All right, I'm not hearing from anybody. Thank you, Avery and Bella. Thank you. Okay, so we're all on the same page. We know where we're heading. Test on Friday, 6-1, 6-2. When I see you again Tuesday, we'll review. 6-2, 1 to 12 is due by Monday. And I will see you then. Have a good weekend.